This is SpaceTime, Series 23, Episode 25. Coming up on SpaceTime. A new kind of magnetic explosion on the Sun. New clues about how planets are formed. And SpaceX to send tourists to the International Space Station. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists have detected a magnetic explosion on the Sun, the likes of which has never been seen before. It all began in the scorching upper reaches of the Sun's atmosphere, when a large loop of material called a solar prominence, which was generated by an eruption, began falling back down onto the photosphere, the Sun's visible surface. But before it could make it all the way down, the prominence collided with a snarl of magnetic field lines, triggering a spectacular magnetic explosion. While scientists have previously seen the explosive snap and realignment of tangled magnetic field lines on the Sun, a process known as magnetic reconnection, a report in the Astrophysical Journal claims this was the first time it was seen to have been triggered by a nearby eruption. The observations confirm a decade-old theory and could help astronomers understand a key mystery about the Sun's atmosphere. It could also help scientists better predict space weather events, and may even lead to new breakthroughs in controlled fusion and lab plasma experiments here on Earth. One of the study's authors, Avishek Shrivastava from the Indian Institute of Technology, says it was the first ever observation of an external driver of magnetic reconnection. Previously, a type of magnetic reconnection, known as spontaneous reconnection, has been observed both on the Sun and around Earth. But this new explosion-driven type, called forced reconnection, had never been seen directly, though it was first theorized 15 years ago. The previously observed spontaneous reconnection requires a region with just the right conditions, such as having a thin sheet of ionized gas or plasma that only weakly conducts electric currents in order for it to occur. But this new type of forced reconnection can happen in a wider range of places, such as in plasma that has even lower resistance to conducting an electric current. However, it can only occur if there's some type of eruption to trigger it. The eruption squeezes the plasma and the magnetic fields, causing them to reconnect. While the Sun's jumble of magnetic field lines are invisible, they nevertheless affect all the material around them, a soup of ultra-hot charged particles called a plasma. The authors were able to study this plasma using observations from NASA's Solar Dynamics Observatory spacecraft, looking specifically at a wavelength of light showing particles heated to around 1 to 2 million degrees. The observations allowed them to directly see the forced reconnection event for the first time in the solar corona, the Sun's uppermost atmospheric layer. In a series of images taken over a period of about an hour, a prominence in the corona could be seen falling back onto the photosphere. As it dropped, the prominence ran into a snarl of magnetic field lines, causing them to reconnect in a distinct X shape. Spontaneous reconnection offers one explanation for how the Sun's solar atmosphere gets so hot. Mysteriously, the corona is millions of degrees hotter than the lower atmospheric layers, a conundrum which has led solar scientists for decades to search for the mechanism driving this heat. The authors looked at multiple ultraviolet wavelengths to calculate the temperature of the plasma both during and following the reconnection event. And the data showed that the prominence, which was fairly cool relative to the blistering corona, actually gained heat after the event. And this suggests that forced reconnection may be one way the corona is locally heated. Now, spontaneous reconnection can also heat plasma. But forced reconnection seems to be a much more effective heater, raising the temperature of the plasma quicker and higher and in a more controlled manner. While a prominence was the driver behind this reconnection event, other eruptions on the Sun, like solar flares and coronal mass ejections, could also cause forced reconnection. And since these eruptions drive space weather, the burst of solar radiation that can damage satellites, affect communications and navigation systems, and black out terrestrial power grids on the Earth, understanding forced reconnection can help scientists better understand when disruptive high-energy charged particles might come speeding towards the Earth. Understanding how magnetic reconnection can be forced in a controlled manner may also help plasma physicists reproduce reconnection in the lab, and this would be ultimately useful in the field of laboratory plasma to help control and stabilize them, one day maybe even providing us with a new, almost inexhaustible power supply. This report from NASA TV.
In the scorching upper reaches of the Sun's atmosphere, the corona, scientists have just seen a new type of magnetic explosion. The explosion, known as forced or controlled magnetic reconnection, is triggered by an eruption on the Sun, which causes tangled magnetic field lines to explosively snap and realign, shooting up particles and energy. The discovery may help scientists understand a key mystery about how the corona, the Sun's outermost layer, is millions of degrees hotter than layers below it. Previously, scientists had only seen spontaneous reconnection, which is not necessarily linked to an eruption or external forcing on the Sun. The forced reconnection event was clearly visible when the scientists used observations from NASA's Solar Dynamics Observatory to look at a wavelength of light showing plasma heated to 6 million degrees. The data showed a prominence, a large loop of plasma moving up from the visible surface of the Sun, the photosphere. In a series of images taken over an hour, the prominence could be seen falling back into the photosphere. En route, the prominence ran into a snarl of magnetic field lines, causing them to reconnect in a distinct X shape. The data from the event showed that the prominence, which was fairly cool relative to the blistering corona, gained heat from the event. The temperature of the reconnection point was also elevated. This suggests that forced reconnection might be one way the corona is heated locally. The scientists are continuing to look for more forced reconnection events. With more observations, they can begin to understand the mechanics behind the reconnection and how often it might happen.
Data from NASA's New Horizons mission is providing new insights into how planets and planetesimals, the building blocks of planets, are formed. New Horizons was launched way back on January the 19th, 2006, from the Cape Canaveral Air Force Station in Florida aboard an Atlas V rocket. The probe made history on the 14th of July 2015, becoming the first spacecraft to visit the dwarf planet Pluto, flying just 12,500 kilometers above the frozen world's surface. New Horizons also studied Pluto's binary partner Charon and their 4 moons Styx, Nix, Kerberos and Hydra. At 2,377 kilometers wide, Pluto is one of the largest known bodies in the Kuiper Belt, a ring of frozen worlds, comets and icy debris circling the Sun out beyond the orbit of Neptune. New Horizons' next encounter was on January the 1st, 2019, when it undertook a close flyby of the 30-kilometer wide Kuiper Belt object 2014 MU-69 Ultima Thule, later given the official name Arakoth, meaning sky in the Native American Powhatan language of the Tidewater region of Virginia and Maryland. Ultima Thule was an ancient traditional name used to describe the most distant place known, a land well beyond the borders of the known world. In ancient Greek and Roman times, Ultima Thule was the place most furthest north, now thought to refer to Iceland or Greenland, although both the Orkney and Shetland Islands were referred to as Ultima Thule in medieval times. New Horizons principal investigator Alan Stern from the Southwest Research Institute in Boulder, Colorado, says the data gathered during the Arakoth flyby has provided detailed information of the object's shape, geology, color, and composition, thereby allowing scientists to answer some long-standing questions about planetary formation. The first flyby images transmitted from New Horizons last year showed that Arakoth had 2 connecting lobes, a smooth surface, and a uniform composition. That suggested it was most likely pristine and would provide decisive information on how bodies like it are formed. Over the following months, working with more and more high-resolution data as it came in, as well as using sophisticated computer simulations, Stern and colleagues were able to assemble a picture of how Arakoth must have formed. Their analysis indicates that the 2 lobes of this contact binary object were once separate bodies that had formed close together and orbited each other at a very low velocity until slowly and very gently merging into one, creating the strange-looking object we see today. The findings, reported in 3 papers in the journal Science, suggest that Arakoth most likely formed during a gravity-driven collapse of a cloud of solid particles in the primordial solar nebula, rather than through an accretion event. Unlike the gentle, slow-velocity process of particle cloud collapse, accretion events involve planetesimals forming larger and larger bodies by slamming together at increasingly higher speeds as their growing mass increases their gravitational pull. Arakoth looks the way it does not because it formed through some violent collisions, but because it formed through a more intricate dance in which its component objects slowly orbited around each other before gently coming together. Stern says the evidence for this conclusion comes from the uniform colour and composition of Arrokoth's surface, suggesting both lobes had the same origin from a nearby material, such as a local cloud collapse, rather than a mismatch of matter from more separated parts of a nebula, as accretion models would expect. The flattened shapes of each of Arrokoth's lobes, as well as the remarkably close alignment of their poles and equators, also points to a more gentle, orderly merger from a cloud collapse. Finally, Arrokoth's smooth, lightly cratered surface indicates that it's remained well preserved since the end of the planetary formation era. These latest papers are based on 10 times more data than the earlier studies, thereby providing a far more complete picture of Arrokoth's formation. Meanwhile, New Horizons is continuing to undertake observations of additional Kuiper Belt objects as it moves ever deeper into this remote region of the outer solar system. It's also continuing to map the charged particle, radiation and dust environment of the Kuiper Belt. The new Kuiper Belt objects being observed by New Horizons are now too far away to reveal any new discoveries like those on Arrokoth. But mission managers can measure some aspects, such as each object's surface properties and shape. In a few months' time, scientists will begin using large ground-based telescopes to search for new Kuiper Belt objects to study, and maybe even find a new target to visit. New Horizons is now 7.1 billion kilometres from Earth, operating normally and speeding ever deeper into the Kuiper Belt at some 50,400 kilometres per hour. To find out more about its latest discoveries, Andrew Dunkley is speaking to astronomer Professor Fred Watson.
Let's talk about New Horizons, the data that they have analysed suggesting that one planet formation theory is a write-off.
This goes back to an old favourite of ours. We haven't spoken about this celestial object for some time, but last year we certainly did because of the flyby of what was then called Ultima Thule at the beginning of last year on the 1st of January. And we saw an image of something that looked like a snowman. This is, of course, an object 6 billion kilometres from the Sun. It's in the Kuiper Belt, that region of space beyond the orbit of Neptune. It looked like a snowman, but some of the later images that were returned from New Horizons showed that it actually wasn't snowman-shaped. It was two pancakes side by side, basically two flattened discs, one slightly bigger than the other, and joined together just as though they'd been placed side by side. The whole thing is 36 kilometres long, and the reason why everybody wanted to look at this, and New Horizons was guided to this following its encounter with Pluto back in 2015, the reason is that this represents one of the building blocks of the solar system. It's part of the debris left behind during the process of planet formation. It's probably made mostly of ice, very strong icy component. It will have dust in it as well, though, and the analysis that has now been revealed in scientific papers comes about, it's more than a year after the flyby, and that's partly because these things take time to analyse, but also, of course, because New Horizons is so far away, the bandwidth that we receive from it is really slow. It's dial-up mode bandwidth, very slow data rates, and so it's taking...
like Australia's NBN.
Something like that, that's right. A little bit better, actually. So the data have taken considerable length of time to get back to Earth, probably most of last year. But an analysis has now been done by a number of different groups who have looked at the structure of Ultima Thule, but I should have mentioned that it now has a proper name. It's called Arrokoth. Ultima Thule was always a temporary name. It's an object of great interest, and now we believe it has done exactly what you said at the beginning, which has knocked on the head one of the two principal theories of planet formation, which leaves the other one, and it seems to fit the bill perfectly for the other one. So what are these two theories? Well, when planets are formed, they basically form out of the disk of dust and gas, which swirls around an infant star. So our sun, 4.6 billion years ago, was an infant star with this, what's called a protoplanetary disk around it. And the basic theories have been been similar in some ways, but the difference between them is really in terms of the violence within which the building blocks interact. So the earlier theory, which actually has a posh name, it's hierarchical accretion. And hierarchical accretion kind of tells you what it's about. It's a hierarchical process. You build things up and they crash, and then you build more things up and they crash. They all start off, of course, with dust particles sticking together, a bit like the fluff underneath your bed.
Or in your belly button.
Well, that's right. Actually, they're not quite as... The belly button fluff is a little bit more dense than the underbed fluff. And that's partly because there are different physical processes in play. What sticks these particles together in the very earliest stages of planet building is electrostatic forces. They kind of come together and join up electrostatically. But eventually, the dominant force is gravity. And so this theory, basically the hierarchical accretion theory, says that particles stick together, they get ever larger, they collide, they stick together more, and eventually you get these things called planetesimals, which are more or less the size of Ultima Thule or Arakoth, several tens of kilometers across. The old theory says, okay, you get these things, and then the planetesimals themselves collide quite violently, and actually sort of blast themselves to pieces, and then all the pieces re-stick together again. And that is the theory that really is not supported by Arakoth, because the alternative is that you've got streams of what you might call pebble-sized particles. So the dust grains stick together and grow to things the size of a pebble. But these are all sort of moving together in streams in orbit around the infant star. And basically, the clouds that are moving within these streams essentially just collapse themselves under their own gravity. They don't go through a phase where they're growing and then they all smash together. They just simply grow. Yeah. So you've got this planetesimal, which is made of pebbles that have all been in the same part of the dust cloud around the sun, as it is in our case. And that's essentially supported by Arakoth because, first of all, the main point about this theory is that the interactions between the particles that are making up the planetesimals are very gentle. They're not violent collisions. They're gentle interactions. And that is supported...
So more like putting together Lego rather than smashing mud into itself.
That's right, yes. Yeah, exactly so. You're sticking Lego together. It's a good analogy, except that there aren't spotty lumps on the side of all these bits and holes that you can stick them into. But the reason why Arakoth supports that view is that its structure. You've got these two pancake-shaped objects side by side, which have come together at a very, very gentle rate. They're described by some of the authors as they basically kiss together. It's such a delicate interaction. One of the scientists who's worked on this work says that if there were spacecraft, there would be docking. There is no indication that the merger was violent or catastrophic. So you've got this sticking together. There's another point about this as well that again suggests a great degree of stability in the early solar system. And that's the fact that these two pancakes are edge to edge. So they're both lying in the same plane, essentially. It's as though they were flat on a table. That would not have happened accidentally, but if they'd been in orbit around one another for a very long time, then you would get this alignment of their principal planes. They would align in the way that they have. So once again, it speaks of things happening in a very, very stable way. And finally, another paper, it's actually a different set of research, but it points out that the imagery we now have back from New Horizons of this object show it is incredibly uniform in colour and composition. It's not an object with great variations in its colour, in its shading, and things of that sort. And so what they're saying is, once again, that points to a uniformity of the objects that made it up, the pebbles that basically went into producing this really remarkable looking celestial object.
That's Dr. Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. Still to come, SpaceX to start flying rich space tourists to the International Space Station before the end of next year. And later in the science report, a new study shows that average global temperatures have now risen 1.1 degrees above pre-industrial levels. All that and much more still to come on Space Time. SpaceX is to start flying rich tourists to the International Space Station before the end of next year. The Hawthorne, California-based company has entered into a partnership deal with Axiom Space to transport 3 space tourists aboard its Crew Dragon 2 capsule to the orbiting outpost. SpaceX has also signed a deal with another company, Space Adventures, to send another 4 space tourists into an orbit flying higher than the space station, probably sometime around 2022. And in 2023, SpaceX will fly a Japanese fashion billionaire around the moon together with some of his artistic friends. That flight was to also have included a prospective female life partner for the billionaire. But despite 28,000 applicants for the life partner position, the billionaire will now make the journey without a potential partner. So far, 8 space tourists have made the journey to orbit before the program was suspended in 2009, all using spare seats aboard Russian Soyuz rockets. The first was Dennis Tito back in 2001, who paid around $20 million for his 8-day journey. Then, when the space shuttle was mothballed in 2011, NASA paid the Russian Federal Space Agency Roscosmos to transport its crew to the space station, with Moscow charging the US taxpayer over $60 million per seat. Now, with SpaceX about to begin sending crew to the space station aboard Dragon and Boeing most likely soon to follow with their Starliner capsule, the space tourism market has opened again. In fact, Roscosmos has announced plans for its own space tourism program, which could include the use of a specially equipped Soyuz capsule. For those who can't afford the multi-million-dollar price tag of an orbital spaceflight, Virgin Galactic and Blue Origin are both planning suborbital space flights beyond the Kármán line, an altitude of 100 kilometers and the official start of space. And they'll be going for a bargain basement price of somewhere around $250,000 per seat. This is SpaceTime. Still to come, we look at Captain James Cook, the navigator. And later in the science report, a new study shows the Greenland and Antarctic ice sheets are now losing ice 6 times faster than what they were in the 1990s. All that and much more still to come on SpaceTime. This month, Australian Sky and Telescope magazine takes a look at Captain James Cook, the navigator. Well, most people know Cook is the first European to circumnavigate the east coast of Australia in His Majesty's Royal Naval bark Endeavour, and then claim Australia in the name of Mother England in 1770. Cook was also a highly accomplished navigator, undertaking 3 voyages of exploration across the largely uncharted Pacific Ocean. Cook first saw action in the 7 Years' War between Great Britain and France and their allies, which spanned 5 continents. He subsequently surveyed and mapped much of the entrance of the St. Lawrence River during the Siege of Quebec, before being commissioned for the first of his 3 Pacific voyages of exploration. This first voyage was to Tahiti to record the 1769 transit of Venus across the face of the Sun. The observations, when combined with those from other locations, were designed to allow scientists to, for the first time, determine the distance between the Sun and the Earth. Once those observations were completed, Cook opened sealed orders, instructing him to search the South Pacific for signs of a long-postulated rich great southern continent, Terra Australis. Cook then sailed through the Polynesian islands, eventually reaching New Zealand, mapping both North and South Islands before continuing west. Then on April the 19th, 1770, Cook and his ship's company became the first Europeans to reach the southeastern coast of a truly massive landmass that we now know as Australia. They then sailed northwards up the east coast. On April the 29th, Cook and his crew made their first landfall on the Australian continent, stepping ashore on what is now known as the Kurnell Peninsula in what these days is Sydney's southern suburbs. Cook originally named the inlet Stingray Bay, but he then scratched that name out and renamed it Botany Bay, after all the unique specimens retrieved by the ship's botanist Joseph Banks and Daniel Solander. After Endeavour's departure from Botany Bay, Cook continued northwards, eventually running aground on the Great Barrier Reef on June the 11th, 1770. They then spent months repairing the vessel at a location now appropriately known as Cooktown on the mouth of the Endeavour River. Once repaired, the journey then continued north, eventually reaching the continent's northernmost tip, which Cook named Cape York, at around midday on August the 22nd, 1770. Cook then sailed west onto Batavia, now Jakarta, Indonesia, and eventually home to England, arriving back in London on July the 12th, 1771. A year later, Cook undertook his second voyage of scientific exploration to the South Pacific, this time in command of the HMS Resolution, continuing the search for Terra Australis, which the Royal Society now believed was further south than Australia. Their second voyage included the use of Larkham Kendall's K1 copy of John Harrison's H4 maritime chronometer, thereby allowing Cook to more accurately calculate his longitudinal position. On January the 17th, 1773, Cook became one of the first people to cross the Antarctic Circle, eventually reaching 71 degrees 10 minutes south latitude. In fact, Cook almost made it to the Antarctic mainland, but was forced to turn back north to Tahiti to resupply his ship. During his return voyage to England, Cook landed on the Friendly Islands, Easter Island, Norfolk Island, New Caledonia and Vanuatu, before making a final sweep across the South Atlantic from Cape Horn, taking possession for England of South Georgia, as well as discovering Clerk Rocks and the South Sandwich Islands. He then turned north to South Africa and returned home to England. Upon his return, Cook was promoted to the rank of post captain, made a Fellow of the Royal Society, and awarded the Copley Gold Medal for completing his second voyage without losing a single man to scurvy. But Cook couldn't be kept away from the sea, and so volunteered for a third voyage to the Pacific, this time in search of a Northwest Passage. He again commanded the Resolution and sailed into the Pacific, hoping to find a pathway east into the Atlantic. After stopping off again in Tahiti, Cook travelled north and in 1778 became the first European to begin formal contact with the Hawaiian Islands, which he named the Sandwich Islands after the First Lord of the Admiralty. He then continued to sail north-northeast, exploring the west coast of North America, making landfall on the Oregon coast before eventually reaching Vancouver Island, and after resupplying set out north again, exploring and mapping all the way up the west coast of what is now Canada and Alaska to the Bering Strait. In a single visit, Cook had charted the majority of the North American northwest coastline for the very first time. Cook then sailed through the Bering Strait heading northeast along the coast of Alaska until eventually becoming blocked by sea ice at latitude 70 degrees 44 minutes north, forcing him to turn back. By early September 1778, Cook was back in the Bering Sea and began the long trip back through the Pacific to the Hawaiian Islands, arriving there in January. However, following a rise in tensions and a number of quarrels between the Europeans and Hawaiians, including one incident over the theft of a boat, Cook attempted to arrest the Hawaiian king on the 14th of February 1779. However, things didn't go as he planned. Cook was struck on the back of the head by villagers and then stabbed to death, falling face down into the surf. Joining us now is the editor of Australian Sky and Telescope magazine, Jonathan Nally.
Captain Cook, of course, he's famous for lots of things, including bumping into Australia and New Zealand a long time ago. But he was also a really top-flight navigator and not too shabby at observational astronomy too. He wasn't an astronomer, and he wasn't, the best astronomer in the world or anything like that, but ship's captains had to know about astronomy back then because all navigation and timekeeping was based on observations of the sky.
This is around the time they were trying to resolve the longitudinal problem, isn't it?
That's right, yeah. You can find out latitude really easily because you've got your star maps, and you just have to look up and see what star is above you, and you know from the catalogue you've got how many degrees south or north of the equator, the celestial equator, that star is. So if that star is directly above you, you know that you are that many degrees north or south of the equator. But in order to work out your longitude, which is east or west, you need to know the time where you are, and you need to be able to compare your time with the time at a central point or a central spot, which of course became Greenwich in the UK. So you needed to know how many hours and minutes you were east or west of Greenwich. And that was really hard to do before reliable, accurate marine chronometers, ones that would keep time accurately over weeks or months at sea, which was a really tricky job. So it's a fascinating story on its own. But yeah, Cook did have the advantage of having these marine chronometers, certainly in his later voyages. I think he was initially skeptical, but he found that they were really, really good. So that enabled him to really pinpoint his navigation and to be able to sail directly from one place to another, whereas before that you'd have to sail to a certain latitude and then sail east or west along that latitude until you got to where you needed to go, and hopefully you chose the right direction and that it was west of you when you went west and not east, because that happened a lot and people got lost. So anyhow, we've got a fabulous story about the astronomy of Captain Cook's voyages throughout the Pacific and how this celestial navigation was just so vital for opening up the entire world and certainly for his exploration.
And this is what they use sextants for too, isn't it?
Yes, sextants were used for taking sightings on the moon and the sun and stars, and would give you angles between one thing and another. And you could use those measurements together with tables of data that had been prepared before you left on your journey to work out, if on a certain date at a certain time, these two celestial objects should be a certain distance apart. So you could then do complex calculations and then work your way backwards and find out what the time was and where you were.
It's a lot easier with GPS.
A lot easier with GPS until someone decides to jam it, or the Americans decide to turn it off if a war comes or something like that. So you know what they're doing in the U.S. Navy now, and I'm sure they're probably doing it in other navies too. They are now teaching celestial navigation again.
Well, Buzz Aldrin practiced celestial navigation on his journey to the moon.
All the astronauts were taught celestial navigation. They all had to know it in case something went wrong with the computers, and they used celestial navigation to double check what the computers were telling them. Yeah, it's a fantastic fallback standard sort of thing. Perhaps doesn't give you the precision that you would get out of GPS, but as I say, they are teaching in the United States Navy now. Their navigators are taught, and not just taught, they have to put it into practice. When they go out, they actually use it, because it's a perishable skill, this sort of thing. So they have to maintain their ability to use celestial navigation again, because if a war comes, one of the first things that's going to happen is whatever adversary is involved will zorch, as I think they call it, the GPS satellite, or at least jam them, and they just won't have it.
What was that other word, zorch?
Zorch. I read that in a Tom Clancy novel once.
Right.
So I don't know if it's a real word or not, or maybe it was a real word in the 1980s, but yeah, they were talking about zorching satellites. That is to say...
Sounds like a Marvel superhero, doesn't it?
That is to say, using a very powerful radio signal to blast huge amounts of energy out of satellite, even if it's a long way away, and overwhelm its electronics and basically fry the electronics.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. And this is Space Time. I'm Stuart Gary. And time now to take a brief look at some of the other stories making news in science this week with a science report. The latest State of the Climate report by the World Meteorological Organization has confirmed that 2019 ended with global average temperatures being 1.1 degrees Celsius above pre-industrial levels. The report says Australia finished 2019 where it started, with extreme heat. The 2018-2019 summer was the hottest on record, and December 2019 saw Australia record its hottest area average day on record, with 41.9 degrees Celsius recorded on December the 18th. In fact, Australia's 7 hottest days on record and 9 of the 10 hottest occurred during 2019. Interestingly, despite the severe and prolonged fire season in Australia, daily total wildfire carbon dioxide emissions generally followed the 2003 to 2018 average. Meanwhile, in a separate report, observations from 11 satellite missions monitoring the Greenland and Antarctic ice sheets have revealed that both regions are now losing ice 6 times faster than what they were in the 1990s. A team of no less than 89 polar scientists from 50 organizations found that the two regions had lost some 6.4 trillion tons of ice in 3 decades. The findings, reported in the journal Nature, suggest that the unabated rate of this melting could cause flooding that will affect hundreds of millions of people by the turn of the century. To reach their conclusions, scientists combined 26 surveys to calculate changes in the mass of the Greenland and Antarctic ice sheets between 1992 and 2018. The authors said that if the current melting trend continues, both regions will be on track to match the worst-case scenario of the Intergovernmental Panel on Climate Change, which predicted an extra 17 centimetres of sea level rise by 2100. A new study has shown that despite 40 years of research and knowledge on the subject by educators, social workers, the medical fraternity, police and the legal profession, gay and lesbian children and teenagers are still the primary victims of physical and sexual violence. The new findings, reported in the Journal of the American Medical Association, show that despite living in a so-called enlightened society, rape and bashing remains the major threat faced by gay and lesbian teens compared to their heterosexual peers. The study was based on 28,811 American high school teenagers. Of these, 87.1% said they were straight, 2.2% admitted being gay or lesbian, 7% said they were bisexual, and 3.7% weren't yet sure of their sexual orientation. Researchers found that over the past 12 months, more than half, a stunning 51.1% of LGBTIQ teens were the victims of rape or sexual assault. And 50.7% were victims of physical assault, of which 11.1% of attacks occurred on school property. So much for the so-called woke society. Researchers from the University of New South Wales have successfully controlled the nucleus of a single atom using only electric fields. A report in the journal Nature claims the discovery has major implications, both for the development of quantum computers and more generally for use in sensors. It means scientists now have a pathway to build quantum computers using single atom spins, without the need for any oscillating magnetic fields for their operation. It also means scientists can use these nuclei as exquisitely precise sensors of electric and magnetic fields, or to answer fundamental questions in quantum science. That a nuclear spin can now be controlled with electric instead of magnetic fields has far-reaching consequences. You see, generating magnetic fields requires large coils and high currents, and the laws of physics dictate that it's difficult to confine magnetic fields to very small spaces, so they tend to have a very wide area of influence, something that's often not wanted. Electric fields, on the other hand, can be produced at the very tip of a tiny electrode, and they fall off very sharply the further you move away from that tip. So all this makes controlling individual atoms placed on a nanoelectric device much easier. Well, what do you get if you cross a duck, a chicken, and all the other bird species we know? You get the wonder chicken, the oldest fossil of a modern bird ever found. A report in the journal Nature claims the near-complete bird skull is close to 66.7 million years old, making it the last common ancestor of all modern birds. Researchers say this little bird's egg sighting because there's very little fossil evidence from before the asteroid hit that killed all non-avian dinosaurs. So this is the earliest direct glimpse of what modern birds were like early on in their evolution, which paleontologists say is a real tweet. A report in the journal Psychology Today has found that psychological variabilities can predict belief in alternative medicine. The study shows that these fake treatments rely primarily on anecdotal evidence, which has no scientific basis. Tim Mendham from Australian Skeptic says people often go for these phony treatments because they claim to be 100% successful, and that's something which real medicine can't always guarantee.
Yeah, it's an article in Psychology Today, which is an international publication. It looks at alternative medicine and also complementary medicine. And one of the things you have to take home is that alternative medicine should more properly be called alternative to medicine. It is not medicine because it doesn't go through proper tests and it doesn't go through trials and that sort of thing to actually prove that it works or doesn't work. If it had done that, if it had been through those tests, obviously it wouldn't be alternative, it would be medicine. But it doesn't go through that, and that's the whole point. But it appeals to people, according to this article, for a couple of reasons. One is that it appeals to the intuitive nature of people, like gut feeling that it must work because it seems to work. It relies heavily on anecdotal evidence and sort of warm and fuzzies, as opposed to traditional, established medicine, evidence-based medicine, which is not perfect, and it never claims to necessarily cure you entirely, and it's a bit hit and miss, and people get a bit disenchanted with that, and they want something that will work 100% of the time, and the alternative medicine people claim they can do that. So it works on this warm feeling that people are not necessarily after evidence. They're not using critical thinking about medical things, which is difficult because medicine is so complicated and so technical. The second thing that this article says about people who would believe in such complementary medicines and alternative medicines is they also have a tendency to believe in the paranormal and having what this article describes as magical food and health beliefs. So in other words, there's a totally different mindset of the people. This is a bit extreme, I think, at times, quite frankly, but it says that there's a different mindset of people who believe in complementary medicine benefits and alternative medicine benefits than there is for those people who might go down to your local GP. They have what used to be called a New Age mindset.
Crystals and all that sort of stuff.
Crystals and all that, but even not necessarily even having crystals, although that probably comes into it as well. Pyramid power. Yeah, this saying that by studies, looking at studies, that people who believe in complementary medicine are also more likely to hold beliefs that violate the laws of nature, like clairvoyance and telepathy and astrology and crystals and all that, energies and emanations and vibrations and all that sort of stuff. Therefore, it's outside of the area of proof. And so how do you explain to people how medicine works? Well, you can't for people like that because basically
it's quantum. That's the line. It's quantum.
Well,
it's all quantum power.
As soon as you hear that word, you should run the other way when it's used in medical terms. But it is that you can't disprove things to these people because they have a different way of judging things. So it's intuition and a propensity to believe in the magic.
You said something earlier which really nailed it for me when you said anecdotal evidence. Humans tend to believe in anecdotal evidence rather than the evidence of experts. It's just a mindset that a lot of people have.
In a way, it's like the weather versus climate debate. People look out and see the weather and say, that's the indication of how things are. They don't understand that climate is a trend over years and decades.
Oh, it was
and
minus 10 in Vladivostok. See, global warming.
I know, exactly. So therefore, with an anecdote is that sort of weather approach. Oh, my uncle, it worked for him, and therefore it's got to work for me. Whereas they don't look at trends and scientific studies and that sort of thing, which is the climate debate, which is the trend, the long term over trends and decades. Because that's too hard. It is hard, and it also means you've got to be patient. And scientists are pretty dull and they're pretty depressing often. They're not necessarily all full of wonderful hype and everything like that, as are the alternative medicine practitioners. So yeah, it's I can cure you instantly on the spot with this herb. It's very sad, unfortunately.
That's Tim Mindham from Australian Skeptics. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free twice-weekly podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, CastBox, from spacetimewithstuartgary.com, or from your favourite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/spacetime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.